my dear students. In this session, we are going to discuss on the important questions and PYQs of the chapter metals and non-metals. Okay, let's get started. First, let us solve the MCQs, that is 1 mark questions. Let me read the first question. The metal which melts when kept on palm is sodium, potassium, lithium and gallium. These are the options. We know that all the metals are hard and they do have high melting point. But there are some exceptions which melt at very low temperature. Among them, the exceptions are gallium and cesium. Yes, we know that these are the two metals which have very low melting point and they even melt by keeping them on the palm. Because of the temperature of our body, it gets melted. So among these options, we have gallium is the correct answer as it is having low melting point. Yes, so you should remember the exceptions that are given in your textbook regarding the properties of metals and non-metals. Yes, then our next question is which one of the following metal is malleable and poor conductor of electricity? Yes, we know that metals are malleable, they are ductile and they are good conductors of electricity. But here the question is which of the metal that is malleable but poor conductor of electricity? Yes, we know that copper is a good conductor of electricity. Lead, it is not good conductor. Actually, it is a poor conductor of electricity. Even though it is a metal, it is a exceptional case. It is a poor conductor of electricity. Then zinc and silver are also good conductors of electricity. So our right answer is lead. It is a poor conductor of electricity. Yes. Then our next question is which one of the following is not the characteristics of a metal? Malleability, ductility, electropositive nature, electronegative nature. My dear student, we know that metals are malleable and ductile. Malleable means what? They can be beaten into thin sheets. Yes, and ductility is a property that metals can be drawn into thin wires. They can be drawn into thin wires. And what is the nature of electropositivity? Means the metals easily tend to donate the electrons. Electropositive nature means tendency to lose electrons. What is electronegative nature? It is tendency to gain electrons. We know that all the metals have tendency to lose electrons because when you consider the metals, they have either 1 or 2 or 3 electrons in their outermost shell. So in order to form the stable octet, they tend to lose these electrons while combining with non-metals. So here what they have given is which of the following is not a characteristics of a metal. Yes, we know that metals are malleable, they are ductile, they are having electropositive nature. But this option which says that electronegative nature, it is wrong. So the correct answer is D because it is not a characteristics. Please observe the question properly. They have asked that it is not a characteristic of a metal. So electronegative nature is not a characteristic of a metal. Yes, let us read the next question. Which of the pairs will give displacement reactions? And the options are zinc sulfate solution and copper metal, magnesium chloride solution and aluminium metal, iron sulfate solution and silver metal, silver nitrate solution and copper metal. For this, you have to see the reactivity series. Once you have knowledge about the reactivity series, then you can easily solve this question. So let me write the reactivity series first. So you know that as you move down the group, the reactivity of this metal will decreases. Yes, the reactivity decreases. And the metals which are placed above are more reactive than the metals which are placed below. Once you see these metals of the reactivity series, you can easily solve the question. See here, zinc sulfate solution and copper metal. We know that the copper metal is very less reactive when compared to zinc. So here the displacement reaction will not occur. Then what about magnesium chloride solution and aluminium metal? Here also aluminium is placed below the magnesium. So it will also cannot displace magnesium from its solution. So the displacement reaction will not take place. Then iron sulfate solution and silver metal. In this case also you can see it is a very least reactive metal, silver, and it cannot replace or it cannot displace iron from its solution. So here also displacement does not occur. Then what about the last option? Silver nitrate solution and copper metal. Yes, copper metal is placed above the silver. So it is reactive than silver. So it can easily displace silver from silver nitrate solution. Yes, the correct option is D. That is, this pair will give displacement reaction. That is silver nitrate solution and copper metal. Okay. Moving on. The next question is, food cans are coated with tin and not coated with zinc because zinc is costlier than tin. Zinc has higher melting point than tin. Zinc is more reactive than tin. Zinc is less reactive than tin. We know that zinc is a reactive metal. So, if food cans are coated with zinc, it may react with the substances that are packed in the can, because of which the zinc is not coated on the food cans. Yes, the correct option is zinc is more reactive than tin. Next, metal oxides generally react with acids, but few oxides of metals also react with bases. Such metallic oxides are. We know that metal oxide, they are generally acidic in nature, but the oxides which react with both acids and bases means they behave both as acid and bases to form salt and water. Such oxides are called as amphoteric oxide. Yes, and the two metallic oxides which acts as both acids and bases are zinc oxide and aluminium oxide. Yes, zinc oxide and aluminium oxide, these are amphoteric oxides. So let us check the options. Here they have given magnesium oxide, zinc oxide, aluminium oxide, calcium oxide. These two are amphoteric oxides. So our correct option will be 2 and 3, that is B. This is the correct option. Then copper is used for making cooking utensils. Which one of the following physical properties of copper is not responsible for sin? Understand the question properly. Here they have asked which physical property it is not responsible for the same, which is not the desired property of copper that is used for making cooking utensils. Let us check. Malleability. Yes, this is a desired property. We need the metal to be malleable so that it can be shaped into desired things. Yes, then high melting point. Yes, of course we are using this metal for cooking, then it should have high melting point. Yes, this is also the desired property. Then thermal conductivity, it is the most important property that is needed. Once we are selecting a metal for cooking purposes, then it should have a good thermal conductivity and the substance should get heated evenly when it is put into the utensil. So thermal conductivity is also required. Then high reactivity. This is not the property that we desire. Once we are selecting the metal, if it is highly reactive, then it may react with the substances that we are using for cooking. So it is not the desired property. Hence, this property is not responsible for making cooking utensils. So the correct answer is high reactivity. Yes, the correct option is D. High reactivity. The next question. The table shown below gives information about four substances A, B, C and D. Identify ionic compounds from the given substances. Okay, observe this table properly. They have given the melting point of the substances and electrical conductivity in solid state and liquid or aqueous state as well. Now we have to identify ionic compounds based on the data given. We know that ionic compounds, they have high melting point. We have to check for this property. And about electrical conductivity, they are good conductors in molten or aqueous solution, but they are bad conductors in solid state. So we should know the property of the ionic substance so that we can easily solve this question. By using this property, we can easily solve the question here. Let us first check the substance A. The substance A is having melting point 295. It is not that much high melting point. And when you see the solid, in solid state, the electrical conductivity is good, they have given. And in liquid state also, it is good. But the ionic compounds are not good conductors of electricity in solid state. They do not conduct electricity in solid state. They only conduct electricity in either aqueous solution or molten state, as there is a formation of ions. So this option will be wrong. Means the substance A is not an ionic compound. Then what about B? It is having high melting point, yes, and it is a poor conductor in solid state and good conductor in liquid state. Yes, this can be ionic compound because it is conducting electricity in liquid or aqueous solution, and also it is not conducting in the solid state, and also it is having high melting point. So this can be ionic compound. Then what about C? This is also having high melting point and this is also poor conductor in the solid state and good conductor in liquid or aqueous solution. So this is also an ionic compound. Then what about D? It is having high melting point but it is poor conductor in solid state. But here liquid or aqueous solution of this metal is a poor conductor. This shows that it is not an ionic compound, as ionic compounds are good conductors in liquid state or aqueous solution. Yes, so the correct options will be B and C. See here, B will be the correct option. The next question is, in the process of galvanization of iron, the metal used for the coating over iron is aluminium, gallium, zinc and lead. Zinc is the correct option. The process of forming a layer of zinc on the iron articles, it is called as galvanization. Why it is done? It is done to prevent the rusting of iron, so that it forms a protective coating on the iron articles and that iron will not react with the moisture present in air. So in order to prevent rusting, galvanization is done. So for galvanization, the metal that is used is zinc. Next, an element X with atomic number 11 forms a compound with element Y with atomic number 8. The formula of the compound formed is, first let us check what will be the formula. Here they have given the X element is having atomic number 11, means this X must be sodium, and Y is an element with atomic number 8. So it will be oxygen. Yes, the atomic number of sodium is 11 and oxygen it is 8. Let us write the electronic configuration. The electronic configuration of oxygen will be 2, 6. See here, in order to write the formula of the compound, we should have knowledge about the valencies. You can see here, it is having one electron in its outermost orbit, in its outermost shell. See here, sodium is having one electron in its outermost shell. So in order to form the stable octet, what happens? It tends to lose the electron. It tends to lose one electron. Whereas in case of oxygen, it is having 6 electrons in its outermost shell. It means it tends to gain 2 electrons in order to become stable octet. Yes, so the combining capacity of this element will be 1, means it will tend to lose 1 electron here in order to combine with another element. Here it will tend to gain 2 electrons, so its combining capacity will be 2. So the valency of sodium will be 1 and valency of oxygen will be 2 here. By having knowledge of this valencies, we can easily write the formula of the compound. Yes, this is Na, this is O, that is it is X, it is Y. The valency is 1 here, valency is 2 here. Just by cross multiplying, you will get the formula of the compound. X to Y. It will be X to Y. What is the correct option here? X to Y. Yes, then which of the following statement is true about the position of metals in the activity series of metals? Copper is below hydrogen but above lead. Iron is below lead and zinc. Zinc is below magnesium but above aluminium. Magnesium is below calcium but above aluminium. You can easily solve this question just by writing the reactivity series. Yes, let us check options one by one. Copper is below hydrogen but above lead. Yes, copper is below hydrogen but it is not above lead. Lead is above hydrogen. So this is wrong. Iron is below lead and zinc. Iron is below lead and zinc. Yes, it is below zinc but it is not below lead. So this is also wrong. Zinc is below magnesium but above aluminium. Zinc is below magnesium but but above aluminum. No, it is not above aluminum. It is below aluminum. So it is wrong. Magnesium is below calcium but above aluminum. See the magnesium, it is below calcium but it is above aluminum. So this is the correct option. So if you have the knowledge about the reactivity series, you can easily solve this question. Yes. Heating of ore in the absence of air for conversion into oxide ore is known as calcination. When we are going to heat the ore in the absence of oxygen, it is called as calcination. If we heat the ore in the presence of air, then it is called as roasting. Okay. The next question. Copper sulfate can be safely kept in the container of platinum, lead, iron and zinc. See here, when copper sulfate is kept in the containers of the metals which are more reactive than copper, then copper will be displaced from its solution. Means there will be a reaction taking place between the metal and the copper sulfate solution. So it is always safe to keep the copper sulfate solution in the container of the metal which is less reactive than copper. Again, you need to remember the reactivity series. See here, in case of platinum, it is less reactive than copper. It is a less reactive. Whereas these three, lead, iron and zinc, these are more reactive than copper. Yes, these are more reactive. So when this copper sulfate is kept in these containers made up of lead, iron or zinc, there will be a reaction taking place between these metals and copper sulfate solution. If you keep copper sulfate solution in the container made up of platinum, then there will be no reaction taking place as it is less reactive than copper. So it is safe to keep the copper sulfate in the container of platinum. Yes, the A will be the correct option. Next, let us read the question. Assertion: iron is found in the free state in the nature. Reason: iron is a highly reactive element. Now the options are both assertion and reason are correct. And reason is the correct explanation of A. Assertion and reason are correct, but assertion is not the correct explanation of A. Assertion is correct, but reason is incorrect. Assertion is incorrect, but reason is. See here, they have given in the assertion that iron is found in the free state. Is it true? No, iron is a reactive element. Iron is reactive. It is never found in the free state. It is always found in the combined form, in the form of its oxides, in the form of its carbonates. In this way, you have seen there are many ores of iron, hematite, iron pyrite, magnetite. Yes, these are all ores of iron where iron is found in the combined state. It is never found in the state. So this assertion is wrong. Reason: iron is a highly reactive element. Yes, iron is a reactive element because of which it is found in the combined form. Then the option A, both assertion and reason are correct. It is wrong because assertion itself is false. Assertion and reason are correct. This is also false as assertion is not true. Third, assertion is correct but reason is incorrect. No, our assertion is not correct. Last option, assertion is incorrect but reason is correct. Yes, assertion is incorrect and the reason, that is iron is a highly reactive element, this is correct. So the option D is the right answer. The next question, which of the following metal reacts with steam or water to produce oxide instead of hydroxide? This question is about the reaction of metals with water. We have studied that metals will react with water to form first oxides, then those oxides which are soluble in water, they will form hydroxide. The metals like sodium, potassium, calcium, they react with water to form first oxides, that is sodium oxide, potassium oxide, calcium oxide. They are soluble in water to form hydroxide. Sodium forms sodium hydroxide reacting with water. Potassium forms potassium hydroxide. Calcium forms calcium hydroxide. So these will not only produce oxide, they will produce hydroxide also. Then what about the last option, iron? Iron will react with steam to produce iron oxide. It will not produce iron hydroxide. Yes, it will. Iron reacts with steam, produce iron oxide. Yes, it is not producing iron hydroxide here. So this will be the correct answer. As iron oxide is insoluble in water, it will not form hydroxide. It will only form oxide, iron oxide. Next, sodium is obtained by the electrolysis of an aqueous solution of sodium chloride, an aqueous solution of sodium hydroxide, fused sodium chloride, fused sodium sulfates. From which concept is this question from? We know that during the extraction of metals of high reactivity, we will we will do the extraction by electrolysis method. Yes, electrolytic reduction. We will extract the high reactive metals like sodium, potassium. And while doing the electrolysis, what we do is we will take the molten chlorides of the metals. Yes, during the electrolytic reduction. What we will take? We will take the molten chlorides of the metals. Suppose if I want to make the sodium, if I want to extract sodium, what I will do? I will take the molten sodium chloride and I will take two electrodes, that is cathode, anode. Then what happens? At the anode, anions are attracted, and at the cathode, cations are attracted. In the molten state, it will be having ions. Yes, so these chloride ions are attracted towards the anode, which is a positive electrode, and sodium ions are attracted towards the cathode. So at cathode, what happens? Sodium ions will gain electrons to form sodium metal. So sodium metal is deposited on the cathode. So what we have taken here? Molten or fused sodium chloride. We are not supposed to take aqueous solution. If you take aqueous solution, you might remember during the formation of sodium hydroxide in the previous chapter, what we had taken? We had taken the brine solution. If you take the aqueous solution of sodium chloride, then sodium hydroxide will be formed. You will not get sodium there. So in order to make the electrolytic reduction, what we do is we will take sodium chloride in the molten form. Yes, the correct option is fused sodium chloride. Okay. Next question. In nature, aluminium is found in combined state, whereas silver, gold are found in free state. Give reason. We know that aluminium is a reactive metal. Aluminium is a reactive metal. So it will always combine with other elements to form compounds. So it will react with other elements like oxygen to form compounds. Whereas gold or silver, they are least reactive metals. Silver or gold, they are least reactive. As they are least reactive, they are found in the free state. So they are found in free state. They are not present in the combined form. You can also observe it from the reactivity series where the silver and gold are placed. They are very below the series, whereas aluminium comes at the top of the series, because of which it is always found in the combined form as it is reactive element. Okay. Next, why do ionic compounds conduct electricity in molten state and not in solid state? We know that ionic compounds, they are present in the form of a crystal structure. Yes, they are having crystal structure where there is a definite arrangement of the ions there. The ions are present in the form of layers in a definite geometrical pattern to form a crystal lattice. So what happens? The ions in the solid state, they are not available in the form of. So what happens? Ions are not available for movement there. When they are present in the crystal structure, these are not available for movement. Means they are not mobile. In solid state, ions are packed in crystal lattice. So they are immobile. They are not mobile. For conduction of electricity, what we need? We need the movement of charges, movement of ions. But these ions which are packed in a crystal structure, they are not available for movement. So they do not conduct electricity in solid state. So ions are not available for motion. Whereas in molten state, what happens? The ions will be free to move. Ions will be free to move. So they conduct electricity. Have you understood why it is the reason that they do not conduct electricity in solid state? As the ions are not available for moving, they do not conduct electricity in solid state. Whereas in molten state, the ions will become free, because of which they will conduct electricity in molten state and aqueous solution as well. Yes. Next, silver articles become black when kept in open for some time, whereas copper vessels lose their shiny brown surface and gain a green coat when kept in open. Name the substances present in air with which these metals react and write the name of the product's form. It is about the corrosion. Yes, you have gone through the concepts of corrosion. What happens when silver is exposed to the open air for long duration? It will react with the sulfide, that is hydrogen sulfide, to form silver sulfide. That silver sulfide is responsible for the black coating on silver articles. Okay. Silver reacts with hydrogen sulfide present in air to form silver sulfide. So, a black coating is formed due to formation of silver sulfide. It will slowly react with the hydrogen sulfide present in air to form silver sulfide. The black coating that you see on the silver article, it is of the silver sulfide. Yes. Then in case of copper, they lose their shiny surface and gain a green coat. Why does this happen? Because copper reacts with moist carbon dioxide present in air to form mixture of copper carbonate and copper hydroxide. Because of the formation of the mixture of copper carbonate and copper hydroxide, the green coating is formed. Now our question is, name the substances present in air with which these metals react and write the name of the products formed. We have written here, it will react with the H2S gas, that is hydrogen sulfide. What is the product formed there? There is a formation of silver sulfide. In case of copper, it will react with the moist carbon dioxide. It will react with carbon dioxide and water, that is moist carbon dioxide, to form mixture of copper carbonate and copper hydroxide. And the color of this mixture is, it is green in color, because of which the copper vessels, they will have a green coat when they are kept open for long time. Yes. The next question is, how are broken railway tracks joined? Give the name of the process and the chemical equation of the reaction involved. The name of the process that is used in order to join the railway tracks is thermite process. Yes. So thermite process is used in the thermite process is used in joining broken railway tracks. How this process is done? The reaction that is involved in this process is the reaction of iron oxide with aluminium. The reaction involved in this process is reaction of iron oxide with aluminium. See, in this reaction, the large amount of heat is released. Lot amount of heat is released, as it is a exothermic reaction. And the heat that is released is so much that we will get iron in the form of molten state. This molten iron is used for joining the railway track. Yes, you have to balance the equation. Then the reaction is highly exothermic, that the iron is obtained in the molten state. This molten iron is used to join the railway tracks. Yes, you have to write, the reaction is highly exothermic. The iron is obtained in the molten state is used to join the railway track, broken railway track. So what is the question here? How the railway track that is broken is joined. You have to write the process that is involved. Thermite process. You should write here. This will be of 1 mark. Then you have to give the name of the process along with the chemical equation. See here, you should write the chemical equation. A balanced chemical equation is need to be written. Then again you have to mention how this process is used to join the railway tracks, because the iron is obtained in the molten form. As the reaction is highly exothermic, it is used to join the broken railway tracks. Okay. The next question. Name the ore of mercury. With the help of balanced chemical equations, explain the process of extraction of mercury from its ore. Yes. Let's solve this. The ore of mercury is called cinnabar. Yes, cinnabar is an ore of mercury. Yes, it is an. Then we have also right here the process of extraction of mercury from its ore. From the ore, cinnabar. Okay, let us write it. The process of extraction of mercury involves. In the first step, what happens? We are going to heat the ore in the presence of oxygen to form mercuric oxide, and then just by heating the mercuric oxide we are going to get mercury in the next step. Yes, once this mercuric ore is heated in the presence of oxygen, we get mercuric oxide. Yes, mercuric sulfide is converted into mercuric oxide. What is cinnabar? The mercury is present in the form of sulfide. Yes, during the reaction mercuric oxide is formed with the formation of sulfur dioxide. Yes. Then in the next step what happens? Just by heating this mercuric oxide we will get mercury. Yes, the mercuric oxide is heated to form mercury. Yes, this is what we need. We are going to extract this metal from the ore cinnabar. Then what happens? heating mercuric oxide in the, not even we required any reducing agent here, just by heating we will get the mercury. This is how we obtain mercury from its ore, cinnabar. Yes, you have to write the balanced chemical equations that are involved in the reaction. Yes, these two are the reactions. In the first step, we are going to heat the ore of mercury in the presence of oxygen to form mercuric oxide, and then mercuric oxide is converted into mercury just by heating, as this mercury is not that much reactive metal. It is a metal of low reactivity. Even just by heating it will lose oxygen to form mercury. Yes, then the next question is, given below are the steps for the extraction of copper from its ore. Write the chemical equation for the reactions involved in each case. Roasting of copper sulfide, reduction of copper oxide from copper sulfide. Last is electrolytic refining. We have to write the reactions which are involved in this process. Yes, first let us write the roasting of copper 1 sulfide. Yes, roasting means what? We are going to heat the ore in the presence of oxygen. Roasting of copper oxide. Roasting of copper sulfide. Once copper sulfide is roasted in the presence of oxygen, we are going to get copper oxide. Yes. Now we have got copper oxide, that is copper 1 oxide. In the next step, that is reduction of copper oxide will result in the formation of copper. Reduction of copper oxide. We are going to reduce copper oxide with the help of copper sulfide to form copper and sulfur dioxide. Yes. Now, in the third step, what we have to do? We have to do the electrolytic refining, as the copper that is obtained from the extraction process is not 100% pure. So, we are going to do the electrolytic refining. They have asked to write the reactions involved in the electrolytic refining process. Let's write the equations here. What we do in the electrolytic refining? We will take an electrolyte here and we will make the cathode and anode such that pure copper is made cathode. Pure, as we are extracting copper here, pure copper is made cathode, and impure copper which is to be made pure is made anode. Impure copper, it is made anode. Now we have taken the electrolyte here for conduction of electricity here, copper sulfate solution. What happens at anode? Let's write the equations here. This is anode and it is cathode. What happens at anode? The oxidation takes place. The copper from the impure copper plate will undergo oxidation, means it will lose electrons. Copper will lose electrons to form copper plus 2 ions, and at cathode the equivalent amount of the copper plus 2 ions will gain electrons to form copper. Copper plus 2 ions will gain electrons to form copper. So the pure copper will get deposited on the cathode here. On the cathode we are going to get the pure copper, and whatever the impurities that are soluble will go into the solution, and the insoluble impurities will be collected as anode mud here. You have to write these all equations. The equation that is going to take place at anode is oxidation, that is loss of electrons. Copper is going to lose electron to form copper plus 2 ions, and at cathode what happens? The same amount of copper plus 2 ions are going to gain electrons to form copper. So pure copper is getting deposited on the cathode. This is how electrolytic refining is done. See the next question here. Give reason for the following. Platinum, gold and silver are used for making jewelry. You have to give reason for this. The reason for using platinum, gold and silver for jewelry is they are malleable. These are metals which are malleable. These are ductile, and important thing is they are lustrous. They are having shining surface, so that the jewelry making which are made out of the metals look very beautiful. Yes, lustrous. And one more important thing is they are not corrosive, and these metals are not corrosive, means they are least reactive. They will not react with the moisture, air or any gases present in air to get corroded. They will not get corroded. This is the reason why they are used in making jewelry. Along with all these properties, they are malleable, ductile, so that we can make any kind of designs out of them. Yes, if they are malleable and ductile, then we can shape any kind of designs on them. And also these metals are not corrosive. They are least reactive, because of which it is suitable for making jewelry. Yes. Then the next question, aluminium is highly reactive metal but still used for making cooking. Yes, aluminium is a reactive metal, but what happens? Aluminium will react with the oxygen present in air to form a thin layer of aluminium oxide. Once this aluminium oxide is formed, it forms a protective layer on the aluminium metal so that it prevents the further reaction of the aluminium metal with the external environment. Yes, so because of the formation of this protective layer of aluminium oxide, it will not react with the environment or any gases or any moisture present in the environment. So it is suitable for making cooking utensils because aluminium reacts with oxygen present in air to form thin layer of aluminium oxide. This forms protective covering on the aluminium. Why it forms the protective covering? Because it is stable. The oxide of aluminium is stable, as aluminium oxide is stable, and it prevents further reaction of aluminium with any other elements. Once this layer of aluminium oxide is formed, it forms a protective covering on the aluminium metal so that aluminium metal will not further react with any other elements. And also why it is used for making cooking utensils? Because it is good conductor of heat, because aluminium is good conductor of heat and it is malleable, ductile, so that the vessels which are used for making cooking can be made out of the aluminium, as it is a good conductor of heat, it is malleable, it is ductile. So these are the properties of aluminium which is very useful for making cooking utensils. Okay. And the next question is, carbonate and sulfide ores are usually converted into oxide during the process of extraction. During the extraction of metals, it is easy to during the extraction of metals, it is very easy to reduce, or it is very easy to extract the metals from their oxide rather than their sulfides or carbonates. Okay, the answer is it is easy to extract metals from oxides by reducing them rather than from carbonates and sulfides. Why these ores are converted into oxides? Because it is easy to reduce the metal oxides. After reduction of metal oxides, we will be getting metals easily rather than by using carbonates and sulfides directly. It is not easy to reduce carbonates and sulfides that much easily when compared to reduction of oxides to metal. Okay, this is the reason why first they are converted into oxides before extracting them. Okay, see the next question here. Name the following a lustrous colored non-metal. Usually non-metals are not lustrous, but there is only one non-metal which is lustrous, that is iodine. Then a metal which melts when kept on palm. Usually metals are having high melting point, but there are two exceptions, that is gallium and cesium, which are having low melting point. Example for a metal which melts when kept on palm is gallium or cesium. You can write any one. A metal which is poor conductor of heat, that is lead, and mercury is also poor conductor of heat. You can write that also. Then a non-metal which is liquid at room temperature. Bromine is the non-metal which is liquid at room temperature. You have to remember the exceptions while studying the properties of physical properties of metals and non-metals. Next, write the chemical equations that shows aluminium oxide react with acid as well as base. We know that aluminium oxide is an amphoteric oxide. What is this? It is an amphoteric oxide because it will react with both acid as well as base to form salt and water. Let us write the equation to see how this aluminium oxide will act as both acid and as well as base. Yes, reaction of aluminium oxide with acid. It will react with acid. Let's take hydrochloric acid to form aluminium chloride plus H2O. You can balance the equation. There are 2 aluminum atoms here. You can write here 2. So that chlorine atoms will be 6 here. Write 6 here. Hydrogen here 6 atoms of hydrogen. Here also you should get 6 atoms of hydrogen. So the equation is balanced. This is salt and this is water. This shows that aluminium oxide will react with acid to form salt and water. Means it will act as base here. Now let us see the reaction of aluminium oxide with base. Aluminium oxide will react with base sodium hydroxide to form salt, that is sodium aluminate. This is salt and this is water. Yes. Here also it will react with base to form salt and water. In this case it is acting as acid. In this case it is acting as base. So it is called as an amphoteric oxide. Okay, we have to write the chemical equation for both. This is called as sodium aluminate. Next, what happens to sodium and potassium if they are kept in open? Why are they immersed in kerosene oil? Yes, what happens when sodium and potassium are kept exposed to air? It will react with the air moisture that is present in the environment to form hydroxides with the liberation of large amount of heat, as this reaction is highly exothermic. As more amount of heat is released during the reaction, sometimes it may catch the fire and it will be explosive in nature, because of which they are always kept in the kerosene oil, because it is unreactive towards the kerosene oil. Okay. The answer is sodium and potassium are highly reactive metals. They react with oxygen, moisture present in air to form hydroxides with liberation of large amount of heat, and it may catch fire, because of which they are never kept open. As the sodium and potassium are highly reactive metals, they will react with oxygen or the moisture present in air to form hydroxides along with the formation of hydrogen, and the heat liberated is so much that the hydrogen will catch fire. So it is always kept immersed in kerosene oil, because sodium and potassium are not reactive towards kerosene. They will not react with kerosene oil. So they are kept immersed in kerosene oil. Okay. Yes. Next, state 2 ways to prevent rusting of iron. We know that rusting of iron is a very serious problem, as iron is applicable in many fields. In construction purposes, for bridges, homes, buildings, iron is used. If iron is corroded, then it will result in the formation of iron oxide, which is a flaky substance. It will deteriorate the metal. So we have to prevent the rusting of iron. How can we prevent it? We can prevent the rusting of iron by oiling, greasing, painting. You might have seen the windows or the doors which are made up of iron, they are oftenly painted, so that an external layer of paint that is formed will prevent the iron from getting oxidized, from getting corroded. Okay, can be used to prevent rusting. And also in many cases galvanization is done. Yes, galvanization prevents rusting of iron. What is galvanization? Here, formation of a layer of zinc on the iron articles. We are going to make the iron article to be covered by the zinc layer. Yes, forming a layer of zinc on iron is called as galvanization. Once this layer of zinc is formed on iron, it will react with the oxygen present in air to form zinc oxide, and zinc oxide is stable. It will prevent the further oxidation of the metal, that is iron, with the air. As it prevents its oxidation with air, it is preventing the metal from being corroded. Okay, so the zinc forms zinc oxide, forming a protective layer, and this protective layer will prevent the metal from being corroded. In this way, this galvanization is recommended for preventing the rusting of iron. Yes. Next, compare in tabular form the reactivities of the following metals with cold and hot water. We know that metals will react with water to form either oxides or hydroxides. Let us see how these metals will react with cold water and hot water. Sodium, in case of sodium, it will react very violently with cold water. Yes, it reacts violently to form hydroxide, and along with the formation of hydroxide, there is a liberation of large amount of heat which causes the hydrogen to catch fire. So the reaction is very violent even with cold water. And if the reaction is very violent with cold water, it will be very violent with hot water also. Yes, extremely violent. with hot water. What about calcium? Calcium also reacts with cold water to form calcium hydroxide, and here also there is a liberation of heat, but it is less violent when compared to sodium and potassium. Yes, it is less violent. And when it reacts with hot water, it is violent in nature. Large amount of heat is liberated. What about magnesium? Magnesium will not react with cold water. It will not react with cold water. It will react with hot water to form magnesium hydroxide. It is not violent. We can also write the equations for them. Sodium reacts with cold water to form sodium hydroxide. And what about calcium? Calcium also reacts with water to form calcium hydroxide. Magnesium, it will react with hot water. Yes, to form magnesium hydroxide. It will react with hot water. It will not react with cold water. Okay. And there is a liberation of large amount of heat here. Then draw the label diagram for the electrolytic refining of copper. Write the chemical equation involved in the reaction. Yes. We have to draw the diagram for the electrolytic refining. We have taken a tank in which we have taken two electrodes, that is cathode and anode. This is anode and this is cathode. What we do here, we will take the pure copper as cathode. This is pure copper is taken as cathode, and impure copper which is to be made pure is taken as anode. Okay, impure copper is made anode here. And we will take the electrolyte solution. Copper sulfate is taken as an electrolyte. What happens here? Once the battery is switched on at anode, what happens? At anode where the impure copper is there, the copper atoms from the impure copper, they will lose electrons to form copper ions. Yes, oxidation takes place at anode. Copper, they will lose electrons to form copper plus 2 ions as they are connected to the positive terminal of the battery here. And these ions will go into the solution, and equivalent amount of this copper plus 2 ions, they are attracted towards the cathode, that is negative electrode. What happens here? At cathode, the copper plus 2 ions, they are attracted, they gain electrons. Each copper ion will gain 2 electrons to form copper atom. Okay. In this way, the copper is getting deposited on the cathode. The pure copper from this thin strip of anode start depositing on the cathode as a pure one. Okay. So whatever the impurities that were present will go into the solution, and the impurities which were insoluble in the solution, they will be settled down as anode mud here. What is anode mud? The insoluble impurities from the anode, which the impurities which are insoluble, they will go into the solution as anode mud. Okay, this is anode mud. And at anode, the oxidation takes place, and at cathode, reduction occurs. Okay, this is how the electrolytic refining of copper is done. Okay. Next, explain the formation of the compound CaO, that is calcium oxide, with electron dot structure. Atomic number of calcium and oxygen are 20 and 8 respectively. Okay. See here, atomic number of calcium is 20 and oxygen it is 8. So the electronic configuration we can write here 2, 8, 8, 2. In this case 2, 6. Calcium has 2 electrons in its outermost shell, and oxygen has 6 electrons in its outermost shell. Calcium atom tends to lose 2 electrons in order to become stable octet, that is completely filled valence shell. In case of oxygen, it needs 2 electrons in order to complete the octet. Yes, let us see the formation. Calcium, it will lose the electrons to form calcium plus 2 ion, that is calcium cation. Why it has tendency to lose electrons? Because in order to become the stable, in order to get the stable octet, it will lose electrons. Initially it was having electronic configuration 2882. Now it is having 288, and it will get plus charge because it is losing the electron. Whenever the atom loses the electrons, it will get positive charge. Whenever it gains the electron, it will get negative charge. Okay. Here this is calcium cation. Then oxygen, it will gain 2 electrons to form oxygen anion. Initially it was having 2 6 electronic configuration. Now it will be having 2 8. This is oxygen anion. And there is an electrostatic force of attraction between positively charged cation and negatively charged anion, resulting in the formation of ionic compound. Yes. Now what happens? Calcium, it is having 2 electrons in its outermost orbit. Oxygen, it is having 6 electrons in its outermost orbit. What happens? It is having tendency to gain 2 electrons, and calcium is having tendency to lose 2 electrons. So it will give its electrons to the oxygen atom, resulting in the formation of ionic compound, that is calcium oxide. Calcium will lose 2 electrons, and oxygen, after gaining its electrons from calcium, it will have completely filled shell. Now it will be having -2 charge. Okay, this is ionic compound calcium oxide. This is how calcium oxide is formed. Okay, so this bond that is formed by the transfer of electrons from metal to non-metal is called as ionic bond. It is called as ionic bond, and the compound that is formed is called as ionic compound. Okay, this is all about the important questions and PYQs of the chapter metals and non-metals.